Hello students, so today's topic atomic structure, and in today's class we take introduction to electromagnetic spectrum. So regarding atomic structure, we have a previous knowledge from previous lower classes, and according to that the atomic structure has been developed according to it has been developed in order to find the smallest particle in the world. So beginning from ancient ancestors like Kashyapa from India and Greeks. So these are all have given their own ideas regarding atoms. So atom, which means smallest and indivisible. According to this knowledge, scientists have developed and finally scientists have researched and discovered what is the structure of an atom. And before discussing about this, in introductory part, we need to take on spectrum. See, spectrum means it is a group of wavelengths or frequencies. The group of wavelengths or frequencies is being called spectrum. In simple terms, spectrum will be the colors that it will show, because a visible portion color is always based on its wavelength. So, reason behind the color of an object is the wavelength of light. Okay, and how this spectrum is studied? See, when Max Planck has given his quantum theory, according to it, every object absorbs some energy and then it re-emits. When energy is re-emitted equivalent to its wavelength or frequency, an object exhibits its color. So this absorption and emission of energy can be explained with the help of a formula. E is equal to h nu, where h is called Planck's constant and its value is 6.625 into 10 power minus 34 joule seconds. And at the same time, where nu is called frequency of radiation. This is Planck's quantum equation. And after observing this, let us come back to spectrum. See, what is the involvement of spectrum in atomic structure? Means all inventions regarding atomic structure have been explained with respect to spectrum. Okay, so we discuss now the parts and the nature of electromagnetic spectrum. See, we already know a word electromagnetic wave. What is electromagnetic wave? A wave that doesn't require a medium to propagate and can travel its speed equivalent to light. Speed is equal to light speed. Such a type of wave is called electromagnetic wave. Electromagnetic waves are created by producing a magnetic field and electric field perpendicular to each other. So this perpendicular electric and magnetic fields will be like this. If this is a vertical field, let's say assume a magnetic field. Then its perpendicular field so this horizontal line symbol is a perpendicular field to magnetic field will be electric field. So this magnetic and electric fields when created perpendicular to each other, then it is called an electromagnetic wave. Electromagnetic wave has majorly three characteristics. Number one, it is produced by perpendicular magnetic and electric fields, and it can travel through vacuum. And the third one is its speed is equal to light speed. So because of these three characteristics, so these three are called the characteristics of electromagnetic wave. And a spectrum which obey the three of these electromagnetic waves, then it is called electromagnetic spectrum. Usually electromagnetic spectrum is not visible, but there is a particular range is visible. So when we arrange these all electromagnetic waves in ascending order of wavelengths or descending order of frequencies, then it is called electromagnetic spectrum. In order of this electromagnetic spectrum, these are the spectrum exist. Among these all the spectrum, there is only one spectrum is visible. This is called as visible spectrum. So visible spectrum has an mid range of its wavelength or frequency, and it is visible. The visible spectrum, lower than the visible spectrum, the wavelengths are going to be so smaller one will goes to UV radiations, ultraviolet radiations. Next in order, X-rays, and in next order, gamma radiations. These are all lower wavelengths than a visible spectrum. If we discuss about upper wavelengths, in upper wavelengths greater than visible spectrum, the first are infrared radiations, IR radiations, and the sixth next in are microwaves, and the next in order radio waves. These are all the part of electromagnetic spectrum. Comparing to each other, understanding each other, so we just need to know what are the sources of these waves and how are these waves useful. Okay, when we discuss about it, the visible spectrum, as it is visible, we are going to have all colors here. We are going to have all the colors here in visible spectrum, and as all colors are here, so visible spectrum importance is to see and recognize what are all the materials around us. And the remaining, when we start discussing about is ultraviolet radiations is produced due to some molecular conditions. So some energy difference that happens in between atoms present in a molecule. These ultraviolet radiations are produced and these are harmful. And we already have some knowledge of regarding pollution. So they are destroying ozone layer. Many pollutants are destroying ozone layer, because why is ozone layer is actually here to protect us from ultraviolet radiations not to reach earth's surface. So these are not reaching earth's surface just because of ozone layer, but nowadays it is getting destroyed. So we are facing many problems, because this can cause severe skin effects and even it can cause cancer. So instead of advantages, we have many disadvantages with ultraviolet radiations. Next, X-rays. X-rays are produced when electrons or cathode rays are collided with heavy metals like molybdenum. During this collision, an invisible radiation is produced called X-rays. These have a lot of uses. So these are useful in treatment of diseases. These are useful in radiotherapy and radiography. Radiography means medical diagnosis, identifying or recognizing the disease. Radiotherapy, curing a disease. Along with that, we also have gamma radiations. Gamma radiations are like ultraviolet radiations, very harmful, but if the frequency is produced from particular elements like cobalt, those gamma radiations can cure cancer disease. Okay, next we go greater wavelengths. First in order we get infrared radiations. These are produced from hot bodies only, and this efficiency is to take photographs in darkness and in others. And similarly microwave ovens and radar signals, telecommunication. In this all we are going to use, and these are produced from high frequency oscillators. Similarly, low frequency oscillators produce radio waves. These are very large wavelength having. Sometimes its wavelength increase maximum 100 kilometers. So 100 kilometers of wavelength means these can travel a long distance. Remember, in this all electromagnetic spectrum, all have different wavelengths and different frequencies, but all can have same velocity is equal to the velocity of light, that is 3 into 10 power 8 meter per second. That is the speciality. So here among this list, the smallest wavelength is for gamma radiations, highest frequency is also for gamma radiations, and highest wavelength and lowest frequency is given to radio waves, but speed is the same for all. These are the electromagnetic spectrum. See, when once the spectrum is formed, observing this spectrum, the scientists have formed have sent these waves through atoms and have produced electromagnetic spectrum. Observing the spectrum, all the inventions have been made. Like the atom, we know it has a nucleus, stationary orbits. These are all discovered just with the support of electromagnetic spectrum. So this is, students, this is introductory to electromagnetic spectrum. Since it is the beginning of the lesson, so I have just made a small video, and after reading this about this electromagnetic spectrum, in the next class I am going to enter into atomic models, what were the inventions made with the help of this electromagnetic spectrum. Okay, and the next class onwards we get into the lesson starting with electromagnetic waves, and further topic is atomic models. Okay, our atomic models in this syllabus directly starts from Bohr's atomic model, but I will take a revision on Thomson's and Rutherford's atomic model also. Okay friends, this is the end of the session.